Okay, let's do one more limit today. Let's do this one. Well, how did it get blurry and unblurry? There we go. Right. So we're going to prove this limit. It's not linear. It's, 1 over x. Again, this is something that we would consider obvious in Calc 1, but we are now going to prove it with an epsilon and delta proof. So let's go. We do our scratch work. Our scratch work is where we get to assume, once again, we've done this a few times, I get to assume that x minus the number that x is going to is smaller than delta. And yeah, we hardly ever use this, but I get to assume that it's greater than that it's greater than 0 as well. But the important thing usually is the fact that this is less than delta. And what I would like to conclude from that is that f of x minus its limit is less than epsilon. And what did we do last time? I took this and I did some algebra to it. So this is, why don't I get a common denominator? I would get 2 minus x over 2x if I get a common denominator, right? Now, okay. So an absolute value of a fraction, I can just do the absolute value of the top and the bottom separately. Also, I can pull the 2 out of the bottom. And on the top, instead of writing the absolute value of 2 minus x, let me write x minus 2. This is the same thing. X minus 2 and 2 minus x are negatives of each other, but since this is inside of an absolute value, it's the same thing. Absolute value of x minus 2 is the same as the absolute value of 2 minus x. And I like that because it's this. I can say that that number is less than delta. But again, I'm worried about this. I don't know anything about this. So why don't we do something similar to what we did last time, just so that we can say something about this. I'm going to pick a number to say that delta is less than or is definitely less than or equal to this specific number. Last time, if you remember, that the number that we chose was 1. We just chose a specific number to declare delta is less than or equal to this specific number. And we didn't put too much thought into it. Why don't we choose 1 again? Say delta less than or equal to 1. Let me put a box around this so I remember that we're assuming that. What would this tell us? Again, I want to make a statement about this. What I know is that x minus 2 is smaller than delta. So x minus 2 is smaller than delta, which is less than or equal to 1 now. So I find my range of x's. So x minus 2 is between -1 and 1. So x is between, well, 1 and 3 again, right? Yeah. Yeah. Yeah, sorry. So absolute value of x would be at most 3. That's the largest absolute value you can have in here, right? And actually, ooh, let me write that again because I'm not sure whether I need the upper bound or the lower bound. But it's true, just, I mean, x is a positive number anyway, so doing the absolute value doesn't do anything to it. So let's see what I need here. If now I go up here, what can I say? This is less than what? The top is less than delta. The bottom, yeah, so when I replace the bottom of the fraction, I think I should put in the 1 here. So, okay, so pay attention to what I'm doing here. Why did I replace this absolute value with 1 instead of 3? It's because I want the inequality to go the right direction. Ultimately, I want f of x minus L inside of absolute values. I want this to be less than epsilon, right? Oh yeah, I wrote that here. I want this to be less than epsilon. So I need a less than. So I have a fraction and I want this to be less than something. What I should do is I should replace the numerator, I should replace the top with something that's bigger, and I did. Delta is bigger than the top, right up here. Delta is bigger than the top. What I should do is I should replace the bottom with something that's smaller, and absolute value of 1 is smaller or less than or equal to absolute value of x. So I replaced absolute value of x with something that is smaller, or maybe not strictly smaller, but less than or equal to. So that's what I did. I replaced the top with something bigger and the bottom with something smaller, right? So I get delta over 2. And, right, so if I just make this epsilon, or less than or equal to epsilon, in other words, delta is at most 2 epsilon. Okay. So what are we going to do? We're going to try delta to be the min, again, of 2 things, this one and this one. So that's our scratch work. Let's go to a formal proof. Let epsilon be greater than 0, and delta be the min of 1 and 2 epsilon. Then if if absolute value of x minus 2 is between 0 and delta, then f of x minus L, now I want this to be less than epsilon. So let me go down to the bottom of the page. I know that that's my conclusion, And maybe I'm putting a premature proof box before I actually justified everything, but I'll do it. That's what we need. And once again, I'm going to run through this, basically the work that I already did in the scratch work. This, if I get a common denominator, it's that, which is the same as that. Now, I'm to the step where I would like to say this is less than something, and I know I can replace the top with delta. The bottom, I basically know I can replace the bottom, but that was the scratch work, so I should write that as part of the proof. So let me do that. Where was this? Oh, it was here. Yeah, that was like this stuff, right? Since absolute value of x minus 2 is less than delta, and delta is less than or equal to 1, again, because that's one of the two things in the min. Delta is less than or equal to this, and also this. We have x minus 2 is between -1 and 1, so x is between 1 and 3. So absolute value of x is between 1 and 3. Therefore, this thing is less than, and again, let me emphasize the strictness of this. I'm replacing the top with something strictly bigger than the top, delta, right? X minus 2 is strictly less than delta. The bottom may not be strict, but as long as one of them is strict, then then this one is strict. And again, on the bottom, because this is the denominator of the fraction and I want the inequality to go this way, I replace it with this. So I get delta over 2. What I really wanted this, which is equal to this, to be less than epsilon. But now look, oops, there's a bug crawling around. Okay, I didn't kill it, I just moved it. Delta is less than or equal to, now I use this one, 2 epsilon over 2. And because we were smart enough to do our scratch work in advance, everything works miraculously. We just get epsilon. And we got it. This is less than epsilon.